Through quantum physics, scientists are only now beginning to learn what metaphysical and spiritual teachers have known for centuries. Things appear to be solid in nature, but on the quantum level, seemingly solid matter are actually smaller and smaller particles until it's just pure energy. In reality, we are all part of one great quantum energy field. Even your thoughts are just vibrations of waves on the universal quantum consciousness.
Discoveries that emerged out of modern quantum theory is that so-called empty space isn't really empty at all.
Through a system of quantum entangled teleportation devices that align
maybe tied to quantum mechanics and frankly quantum entanglement.
Is more
this is
spread out than.
But actually, our bodies are also quantum. We know that.
Because quantum computers live in the quantum world. Immortality is, therefore, possible.
Wait, is this really what quantum physics says? Because it sounds like a whole lot of bullshit. Today, we're going to learn about everything quantum. And here to separate quantum fact from quantum fiction is our guest. He's a science author with numerous books on quantum physics, including Quantum Bullshit. Here's my conversation with Chris Ferry. Really loved your book. Quantum Bullshit. And I got to tell you already, okay, because I have a lot of these pseudoscience type people on the podcast, spewing a lot of these ideas. So I might not just be whoring quantum bullshit. I may be running an entire quantum brothel. So it's great to have you on. I like to bring on people with, legit science backgrounds and people that could shed light to some of these subjects too. And I got to tell you, one of the things is anytime I bring on anybody that has a, serious background in science, I said, do not ask me about any of this nonsense that relates to quantum. And so I'm so glad that you're here to straighten this out. So could you please, for our audience, tell us, your background and what brought you to write the book Quantum Bullshit?
Right. Well, I guess I'm just a regular academic. I did my PhD in mathematics and physics, and then did research that led me down a path into quantum. And then, you kind of get locked into these things, you specialize and specialize. So I never really wanted to be like, when I was a child, it wasn't like, oh, I need to study quantum physics. I found myself on that path, and it was interesting enough that I stayed on it and did some research, and then eventually became a professor, following where the jobs were. And that's what brought me to Australia, where I lead a research team doing quantum technology, quantum artificial intelligence, and that sort of thing, research. And that wasn't enough for me, I guess. So I started writing books. My writing started with children's books, actually, because I have kids of my own. I wouldn't have written children's books had I not had children of my own. And there was no books about science. There's like nonfiction books for babies, like My First Letters. There's a ton of books about animal sounds for some reason. And there was nothing on science. So I thought, oh, I'm going to write something about like real science, modern science. And the title Quantum Physics for Babies popped into my head, and I thought, oh, that's perfect, right? If nothing else, it's going to get some double takes when it's on the bookshelf. And then my kids grew older. They're not babies anymore, so they don't read the kids' books. And I also communicate with adults often, so I thought, why don't I start writing adult nonfiction? And it's just kind of sarcastic, dry humor is like my everyday thing. So that's where Quantum Bullshit came from.
I love it because, I think the fact that you're able to write this for, quantum for babies, it made it more palatable when reading, Quantum Bullshit. So I really liked it. And, they say, Richard Feynman said back in 1964 that he can safely say nobody understands quantum mechanics, but you do enough to write several books, at least.
Yeah. I think there's different, it really depends on what you mean by the word understanding, of course, right? So we like to think that we understand all the things that come natural to us, right? Like do you understand how a doorknob works? He'd probably say yes. But then if I asked, okay, could you build one from scratch? Like what's going on inside the doorknob? He might stop and think, actually, I don't know how a doorknob works. Uh,
Yeah, we're
so
definitely
yeah,
not as
so
smart
I
as we
think
think we are.
yeah, so everyone who does quantum physics for a living, they've done it for 10 years, right? They put their 10,000 hours in, probably more. So I would hope that they understood it. Otherwise, they wasted a lot of money on these degrees and time.
Well, some would say everyone wastes their money on degrees. Well, but except for you, because you actually are doing what you went to school for. But hey, one of the things that, the reason we got you on, we want to, tackle some of these, pseudoscience topics that you talk about in the book, and you kind of you shed light on some of them because it is like every single person that's peddling the nonsense, they will throw in, oh, quantum something or other, and next thing you know, oh, it must be real. It's like you say in your book so many times, like sign up, buy this or that. So you Google, you get on the YouTube sphere, and it's like this is somehow quantum is connected to time travel, to telepathy, and other dimensions. So there's some of this that is true, and there's some of this that we're hoping you could shed light on. Let's just start where it all began. So if you had to explain to complete novice, a baby, maybe a little bit older than baby, right? At least middle schooler. How would you say that it all began? It with this Max Planck, right? So how would you describe the kind of the quantum theory or physics in general? So when people hear this word, it's not so scary.
Yeah, I mean, there's a modern take and then there's like the historical take. I think when you learn about quantum physics, you often go through the historical version, right? This like chain of geniuses that discovered this theory. It at the time, like in the early 1900s, right? So as you said, Max Planck, 1900, came up with the quantum hypothesis. So there wasn't very many people working on this at the time. They're studying thermodynamics, which was like the physics of the day. Lots of unexplained experiments and questions. And there was this one experiment, it's called the black body radiation problem. It's familiar to everyone. It's just like when something gets hot, it starts to glow. But thermodynamics and electromagnetism, classical physics couldn't explain why that was. It couldn't describe the exact color or intensity of light that was coming off like an iron when it gets hot. So Max Planck, he found some formula. He just picked it out of thin air, basically. Well, he tried and failed lots of times, and it came up with a formula. And then he tried to get the formula to work. And to get it to work, he said, well, the energy coming off has to be like in discrete chunks, and these were called quanta. So his hypothesis was like energy comes in discrete chunks. And why? Well, it just worked. Like that's what made the math work out and fit the formula. And then other people started to do similar things for other experiments. Let's try out Planck's hypothesis, make things discrete, right? That come in chunks rather than continuous, how we might expect things to be based on our everyday experience of the world and based on classical physics. And it just kept working and working and working. But they're all like little hacks. Like nobody could explain why it worked. They're just these little hacks. And then in 1925, Heisenberg and Schrodinger both came up with like a framework, a mathematical framework that kind of fit all of these things together. And if you look at your calendar, you'll see that's 2025. So that's 100 years ago, and that's why 2025 is referred to as the International Year of Quantum Science. All scientists, all
I had
scientists,
no idea.
all scientists know this.
I don't know if you knew this
But
audience, but this is the
but
year of quantum. That's
yeah,
right.
yeah,
Okay, this is nerd
main,
talk right now. We're getting
yeah,
deep
yeah,
into it.
yeah,
All right.
yeah,
All
yeah.
right.
The UNESCO just had a big celebration in Paris
That's how
last
you know
night.
you're legit, Chris. When you're celebrating quantum year.
Yeah. Um, yeah, so the modern, I think, and then we've learned a lot, and probably I would say the modern version, the short version is like this. If you have something that's isolated, like completely isolated, there's no interactions with it, no environment, then you need a different set of rules to explain its behavior. Right? If you try to use classical physics, you're just going to end up being wrong. There's just a different set of rules for things that are isolated. And tiny things are isolated. If you've heard anything about atoms, you'll know that people tell you if you look at your hand, it's mostly empty space because atoms are tiny and the space between atoms is huge and the space within atoms is huge. So there's basically nothing there, right?
Right, which was one of the kind of mystical realms where
Right.
this is proof that you are there's a spiritual being because you're really mostly nothing. That's right. Okay. What are you? Consciousness. We don't know what it is. All right. And it's all proven by quantum.
Right. Yeah. I mean, so it's funny because there's some aspects of like real scientific facts or concepts get mixed in to these things. But most of the time, when you see the word quantum, it's just slapped on like a label that is kind of like name dropping. Like if you're in a conversation and you press someone on something, they just like drop some famous person's name or some authority's name to get you to shut up and stop asking questions. That's the way quantum is used most of the time. It's the quantum part doesn't refer to anything specific. The person doesn't know anything about quantum. That's why my definition of bullshit in quantum bullshit is not that it's a lie, it's that it's untruth, right? The person doesn't To lie, you need to know the truth, and oftentimes the people don't actually know the truth. So they just slap quantum on it because it sounds mysterious and it has this illusion of authority, right? Because there's a public perception that quantum is mysterious, and it's done by Einstein's, people that won Nobel Prizes. I'm not going to be smart enough to figure it out. So if it has something to do with quantum, I better just trust, right?
Right. And here's the other thing that it goes to that I feel like a lot of the pseudoscience out there, the peddlers of the kind of just spiritual and the kind of the guru sort of nonsense is that, oh, well, this is happening on such a small atomic level that's why these things are true because you can't even see. So that's where I want to talk to you about that because sometimes it kind of seems to correlate because I don't know if you're familiar with like, some of these more esoteric thoughts like everything is in motion. The universe is always in moving. And then, this has been being said for, hundreds and hundreds and hundreds of years. And then all of a sudden we get quantum physics comes along and they go, oh, wait a second. We got these things called waves. I told you everything was moving. So how does that? So can you explain what that really means? Because this comes into like the double split experiment, and you talk about this in your book too, and how that kind of like it really has nothing to do with or you could the similarities or just explain the truth behind it.
Right. So as I said, you look at your hand, it's made of atoms, right? You look around you, everything's made of atoms. So in some sense, everything is quantum mechanics.
Mm-hmm.
There's just one theory, quantum physics. It in principle explains everything. But as you get more and more, right? Like you look at your hand again, and it's like billions upon billions upon billions of atoms there, right? So once they all start coming together, they behave in ways that allow us to create effective theories that are much simpler. Because if you had to model every single atom in your hand to know how to pick up a cup of coffee, it would never happen, right? So you have these effective theories like Newton's laws of motion from 300 years ago that are way simpler and work, but they aren't strictly true, right? They just kind of are simplifications or approximations to the real thing. So at that level, like our everyday level, we're using like Newton's laws to navigate the world, forces, push, pull, intuitive concepts, and they aren't written into the laws of physics, right? They just work well, and they work well enough that we use them and we trust them. And when we phrase concepts, these all work together, and we phrase concepts together at this level, and there's no rhyme or reason why it works. Like you could take an evolutionary picture, like this is the thing that works, and so that's what we have, right? If something else worked, then we would have that thing instead, right? So evolutionarily, this is what worked, and so this is what survived. But it's not written into the rules of quantum physics. So the problem is like you keep going back and forth, like, okay, quantum physics says this, but my everyday experience says this, and they seem like they're connected. So maybe I can, manifest whatever from the quantum world. But that's just not how it works, right? If you wanted to be strictly accurate, you would only use quantum physics and you would never reference anything other than quantum physics. But I promise you, if you tried to do that, you wouldn't get very far.
Well, it certainly is very confusing. I like how you're able to wrap your mind around it, but I'm still stuck at maybe the beginning of
Well, look, okay,
the
so I think waves is a good example, right? So
yeah.
there's lots of kind of like a wave to a mathematician is like just something that repeats in time or space, right? So you think a water wave, yeah, it repeats in time and space. Waves hit the shore, right? Um, Sound waves, that's another kind of wave, right? Pressure vibrations in air hit your eardrum. That gets turned into electrical waves as it goes through your nervous system. So like there's all different kinds of waves. Sometimes they connect, right? Like water waves connect to sound waves because the crashing of the water creates pressure in air. But not every type of wave connects to other types of waves. Like water waves don't create electromagnetic waves, right? So you you can talk about waves, but if you don't really understand the difference between all these different types of waves, then what you're saying is probably going to be nonsense, right? So
Like
yes, at the quantum level there are waves, but those don't connect to sound waves and water waves and other kinds of vibrations.
So I love that you're saying this because this is one of the theories that we hear the most. This is the universal consciousness. That is, we are all one. I don't know if you know this, Chris. You're in Australia, but we are actually all one thing. Okay. And
Right.
this is because of quantum. I saw this on Google. Okay. When did you? I've watched entire YouTube videos on this. This is because we're all connected at the quantum level. But you're saying that these waves aren't actually connected. They may seem like they are, but they aren't. Is that what you're saying?
Well, maybe that's where my headaches come from. Yeah, that's right. So it's funny because a lot of times, like I said, some of these things they contain like this kernel of truth, right? So you don't even need quantum. Just take gravity, right? What is gravity? Gravity is a force between any two massive bodies, any two things with mass. So there's a force of gravity between everything in the universe. Right? There's a force of gravity on you from the Earth, that's obvious. There's a force of gravity on you and the moon, right? That's less obvious, but you can calculate it, and like measuring instruments can actually show that when the moon's on the other side of the Earth, there's a different force. That's where the tides come from. Um, so, but there's a force on you from Jupiter and the stars, but it's imperceptibly small, right? So the force on you from any of the stars that you can see in the night sky is the same as the force on you from the International Space Station, right? Do you feel that going over your head? I should hope not, but because
Let me
it's
check my
about the
crystals.
same. It's about the same as force as it takes to press down a key on a keyboard. Um, so you can calculate all these things. Yes, there's a force between everything, but the point is, you can calculate it. Like you can quantify it and show that it's irrelevant.
So when you hear of these things like quantum consciousness, which all this is all on the same of these waves, right? This is how it's sold. This is a new thing that now they say quantum consciousness, this is the universal mind. So when you hear something like that, have you looked into any of these theories, or do you just gloss over it, or what do you say back? Do you say, okay, listen, it may seem like there is some sort of connection, but in actuality, in actual quantum physics, there is no evidence that supports any of this.
Right. So there's a lot of things that go under this title, quantum consciousness. So there's actual
Mhm.
research. People who study consciousness or biology are
Mhm.
trying to probe deeper and deeper and deeper, and then find out where you really require quantum physics to describe the interactions between molecules or biological cells, things like that. So some people say, well, the processes that happen in the brain, in individual neurons, you might, if you really got down deep into it, you might require quantum physics. But it's unlikely. Like even though they're small, neurons are still big on the quantum scale. So it's unlikely that you actually would need quantum physics to describe anything that they do. But of course, the further and further you dig into it, the more and more quantum physics will become relevant. That's like the actual research, and that's legitimate. but the same word gets applied to nonsense. And my approach to nonsense is like a spam filter on your email inbox, right? So if you click on your spam folder, there's probably like hundreds of emails in there. You know the ones, right? But those aren't all the spam, right? Your internet service provider doesn't even send you the majority of it. Like they already get rid of most of it before you even see it. And then some of it ends up in your inbox, but is like flagged by your email program. So it's kind of like, it's not really certain it's spam, but it thinks it might be spam. So there's different layers and levels. So for me, it's like, I can just look at it and almost immediately, for most cases, just ignore it. And if someone comes to me and they really want to know, right, they want to engage in good faith, then I'll try to explain to them why they're wrong. But most often they're just not open to accepting that they're wrong. So the nonsense comes with like different layers of sophistication as well. But the vast majority of it is like the vast majority of spam. Like it's easily dismissed, right?
Well, it seems like we're hearing a lot of reoccurring of the same terms over and over again. And I don't know if you're familiar with this. You described this one in the book, but this is one that it is now in there. I mean, I don't know if you've ever heard of it's a new podcast, or it's a pretty popular show. I don't know what it is, called the Telepathy Tapes. Have you ever heard of that?
No.
And Rogan's been talking about it. It's pretty viral, where these kids with autism are able to read their parents' minds, and if the researchers behind it, and even people like the Hal Puthoff, who's a very popular name in these worlds, and he worked in some government programs, but they say it's because of something called quantum entanglement and quantum non-locality. That now explain to me, when you hear something like that, I mean, what's your first reaction?
Bullshit. No, it's comical. To me, it's comical nonsense. And the more I think about it, the more confusing it gets. But from a psychological perspective, like I can't put myself in the mindset, and maybe this is a good thing, of someone who's delusional, right? And these people are completely irrational. Like I just don't even know what their world looks like, what their internal experience of the world is. Because I think most people have this idea that, like, they look around at other people and they say, oh, your experience of the world is similar to mine, right? Sitting in front of a computer, easily interpretable senses come to my mind. But delusional people, what is fucking going on? I have no clue. Like to think these things is so irrational that it boggles my mind. Like it's not a physics question, it's a psychological question.
Well,
That's not how it works. Like that's not how entanglement works. Entanglement is
yeah.
a very particular kind of interaction that happens at the level of, again, of small tiny things like atoms and particles. And you can, I mean, you can show all sorts of things, like the fact that the bigger they are, the more fragile it becomes, and like the correlations between them will disappear almost immediately. Like,
See, I like that. So that's one we should get into a little bit deeper, because the way they say it, they gloss over it really fast. They go, "Oh, well, it's proof of faster than light travel, because one atom is having communication with another atom across the universe. Doesn't matter how far away it is, and that is proof of how people are able to send telepathic thoughts to your mind far away. And this is part of, again, the universal consciousness, because these things, and it's proof in the quantum level. So explain how, what you said is perfect. The bigger it gets, it already starts to break down. So
yeah,
attack that
so
argument.
we can, the first thing to, I think the way that you should think about entanglement is correlation between between, say, atoms. Let's just say atoms. Two atoms, they're correlated in the way they behave, right? That's not, I mean, it's funny because I said this in the book. The word correlation often scares people, but like often people think that a word like energy feels like a natural thing to say because their parents told them, oh, you need to eat some food because you don't have enough energy. or yeah, you need to take a rest to recuperate your energy. But if you ask someone to define what energy is, most people wouldn't be able to do it. In fact, scientists can't do it. Like if you look up a definition of the word energy, it's some convoluted thing about what happens when you measure something else and things change, right? So, but the correlations are actually simple, right? It's how we navigate the world, right? I mean, the data that I'm seeing on my screen is the same as the data that you're seeing on your screen. They're correlated, right? So correlations are how we navigate the world. And quantum correlations are just ones that happen with atoms. So entanglement is just it's just a name that we invented for correlations of quantum things. And they're no different than the correlations that we observe in the world. So if I put identical letters in an envelope and keep one envelope here in Australia and give you one envelope, and then we open them at the same time, they'll say the same thing. Is that surprising, right? It's that's exactly what's going on. There's no faster than light travel, even though you immediately know what's written on my piece of paper. Nothing travels faster than light, right? And to utilize quantum correlations, it's the same thing. Like if I want two atoms to be correlated, they have to have been together at some point in time. And then I separate them, and then they'll behave in the same way. So there's no influence that travels faster than light. It's just that once you look at one of them, then you know what's going to happen if you look at someone on the other side of the world looks at the other one. There's no influence there. Nothing travels faster than light, and you can't control anything. So it's like all of that is just nonsense.
But if you said this, you wouldn't sell any books if you said that, Chris. You've got to. I don't know if you just flipped your if you flipped your thoughts around, maybe you're New York Times bestseller.
Yeah. I want. Yeah, you probably won't invite me back on. I think I don't get invited back on to many podcasts because it's just like, well, that guy was boring. He just shoots down everything.
No, that's exactly why we want you. We want you to be on, to shed some light on shed some light on these subjects because nobody wants to go down the rabbit hole. People throw these theories out there, and nobody can really explain because what can you do? We don't know anything about quantum. You say the word quantum, we don't know. So automatically, you win the you win the argument. So I'm glad that you're doing this. So, one of the things that is again, right down that path there is this theory of like other dimensions. Okay, so you throw out the word quantum immediately, even when we had the Google computer that came out a few months ago, and they said this thing is going through other dimensions. And when people hear that, they go, "Oh my God, I told you." Many worlds. Have you ever heard that? It's a guy named Hugh Everett, right? He made this. Many infinite versions of us, Chris. And there's just another universe where I'm the smart one explaining quantum, and you're the dumb guy here in California. So, can you are you familiar with this this topic? I know you do work in quantum computing, right? You know this. So can you break down this idea and kind of debunk some of this for us?
Yeah, I guess I should also just say like things about entanglement that like travel faster than light or instantly communicating or changing one thing changes something else on the other side of the planet and things like this many worlds, like these are legitimate scientists sometimes saying these things and
With books for sale.
Yeah, with books for sale. So I don't, yeah, I every time I see that, I lose a little bit of respect for them as well, because they are contributing to the problem, right? So it's one thing for someone without credentials to say, make a post on social media about multiple dimensions, but when a legitimate scientist says it, and then a journalist has they have, what are they going to do? Like, are they going to trust their expert? For this kind of quantum bullshit, it's entirely our fault as scientists for saying these things. Other dimensions, there's no theory that shows how you would access them. So in some sense, who cares, right? There's no way to prove that they exist. So it's just a silly idea, right? There's no way to prove that there isn't a pink elephant sprinkling fairy dust and rainbows on me, then that's where I get my inspiration from. If I say that, but offer you no way of proving it, is that a real theory? Right? So the other dimensions are like that. It's just a silly idea that, people who usually have tenure and have given up on doing real science come up with, because there's nothing to stop them. They're still going to get their
Yeah, because you do
salary.
hear like a Michio Kaku talk about this. He'll get on Rogan and talk about, the the billions and billions of infinite
Well,
different
look, they're
possibilities and
they're humans too, right?
right.
So I can't fault them for that. So they go on and they say, actually, quantum physics is really boring. It's like some equations that we use to, help us do engineering, and then they don't get invited back on the podcast. But if they say, hey, look, there's multiple universes, and there could be a version of you in the other universe, and maybe they're smarter than you, and you can get inspiration from them, and then all of a sudden they get all these views and get invited back onto the podcast, and they're like, they it's funny how quickly people sell out.
Well, I guess that's how Marvel movies are made, right? We need somebody to be talking the nonsense. But it is becoming more and more prevalent today. You hear this, you get, entire stores are devoted to crystals that can access quantum energy. There's another one. What is quantum energy? Is this something that I can harness if I get some quartz?
It's like I said,
It
there's
it's a real thing.
there there's there's atoms inside the crystal, right?
Oh, yeah,
And
I feel the clicks coming. Okay. We're
yeah.
getting views right now. Keep talking. Say
Yeah.
quartz.
There
Click.
there are atoms
Atoms and
inside the
crystals.
crystal,
Okay, go on.
and if you wanted to describe how those atoms exchange energy with the surrounding environment at the level of individual atoms, you would need quantum physics to describe that. So the exchange of energy is always discrete, but the sheer number of them makes it as if it might as well be continuous. So you can't really, with your chubby hands and your stupid ideas, access them at the quantum level, right? You need a lab with extreme environments. Like some of these environments, like vacuum close to that of outer space, you have these liquid helium refrigeration units that inside are the coldest places in the universe, right? We've engineered these environments so that we can probe this level. The idea that some peddler on a beach is going to achieve the same thing is just stupid and embarrassing.
All right. So there is quantum energy. We just can't access it the way people would
Yeah,
like. You can't buy it.
everything is quantum, but you have to ask yourself, is it relevant? Right? Does
Okay.
that help me? Does that help me in my day-to-day life? And the answer is no. Like you're wasting your money, you're wasting your time. Like just be happy with the everyday world that you experience, and stop looking for magic solutions. They don't exist.
And if there were magic solutions, they're non-local. So that's another one. Non-locality. Here's another one that's thrown around nonstop. Okay, this also goes back to, one time I had on one of these guys that was a part of the CIA remote viewing program, remote viewing Project Stargate. Okay, he's got a couple books and a program if you want to learn how to do this. And he said it's because of non-locality. Non-locality. What the hell is non-locality, and what does that have to do with quantum anything?
Well, that's certainly the most difficult one to explain. So there is something interesting. Like the quantum physics isn't just, oh, here's some silly science theory that only scientists need to use when they, are describing what people might perceive as pointless lab experiments. Um, it's there is something interesting there, and non-locality kind of gets towards it. So like what we really learn, I think, from quantum physics is that at the fundamental level, uh, you, there's no such thing as objective reality. There isn't a world out there that's just as is, and it will behave the way it's going to behave, regardless of whether I'm here to to take a look at it, because for me to look at it requires an interaction, right? And for everyday big things, like imagine you're looking at a chair, right? And what does that mean? It means light from somewhere came and bounced off the chair and went into your eye. Okay, so light is physical. It's a thing. It carries momentum, so it imparts something on the chair, right? But it's tiny. Now, imagine, so another way to think about it is like, imagine trying to, imagine instead of little particles of light hitting things to find out where they were, you had to throw baseballs at them. Like obviously, that's going to have an effect. And that's what the real world is like at the fundamental level. If you want to observe something, you have to interact with it, and then you're going to kick it, and it's going to give you a kick back. At the tiniest level, this is really important, right? Everything that you want to observe about atoms and particles, it feels those kicks, right? So at the tiniest level, there is no like objective reality. There's no reality that's just sitting there and we're allowed to passively observe it, right? We have to kick it. And if we kick it, we change it, right? So that I think is the most profound kind of lesson we learn from quantum physics.
Okay, so what you're okay. Oh, I'm sorry. Keep going.
Yeah. So what we want to believe is that there is like this reality. So there's like some real state of the world, and I can write it down, like describe it with mathematics. I can, write it down. The chair is there. It has, this color. It's not moving, right? But at the fundamental level, we can't do that, right? It just, there's no way to do that in a way that is consistent and makes sense. So now you imagine saying, oh, I want to, by the way, like such a theory would be called local, because there is no like things in one place don't interact with things in another place. So if I could write down a state of reality that obeys Einstein's theory of relativity, that's the word we use. We call it local. It's a local theory. So in quantum physics, we can't have such a theory. There's no like state, there's no way to write down any mathematics. So someone proved this mathematically. You can't mathematically create a theory that describes what we see in quantum physics that has this sort of passive reality and that is local. And most people, when they see that, they think, well, okay, so one of those two things has to be false, right? Either it's non-local and things influence each other instantly, or there is no reality. And when people are presented with those options, they typically want to preserve reality and say, okay, well, then it must be non-local. But there are other results in quantum, in the theory of quantum physics that just show you that no, it makes sense intuitively when you think about how you actually have to interact with the world. Like what it means to interact with the world is to actually touch it and impart something on it, and what there wasn't something there that you could just passively see, right? Observation is an active process. If you want to hear something provocative, there is no reality.
All right. Now people are tuning in. They want to know about no reality. So it sounds like non-locality that's the term to use. That is, when I meet the girl at the yoga class, she's leaving yoga class and I want to sound mystical. You just throw some, it's non-locality. Okay, we are all connected. Where I've got my crystals on, okay? I'm meditating, and right now I'm in the metaverse right now. So, so it sounds like we shouldn't be as scared should we be scared of quantum or shouldn't we? Is it as powerful as we think? Because I read this. Did you know that China has the highest amount of patents with the word quantum in it? So they've got the most amount of quantum technologies. Is this something that we should be worried about? You hear this, you go, oh no, they're really harnessing, the power of the universe.
Well, yeah, I guess in a sense they are, right? So what is advanced engineering seems to be just getting finer and finer control over the world, right? And that usually means smaller and smaller things. So in some sense, quantum technology, it has to be the future. It's like the inevitability, right? Uh, we make our computer chips smaller and smaller and smaller, and eventually they'll be so small that we're just doing quantum engineering because we've got to the size of individual atoms. So it is important. Like if you're kind of worried about, uh, competing nations and their technological capabilities, then quantum has to be something that you are worried about because it is an inevitability.
So this is where it gets important. So that's where it takes us to, quantum computing. So this is where it's factual. This is where like the reality of quantum starts to settle in. When we hear of going back to the other dimensions, the quantum computer, it's computing in other dimensions. Is this really
No.
happening? Is it happening like it's not? It's not happening like what we're thinking.
No.
So when they're saying that,
So, what a quantum computer does is, exactly what a conventional like, digital computer does, like your phone or
do we need
your
to
laptop.
change the way we think of dimensions? Is that what it is? Is it because I'm thinking of Doctor Strange and the many Marvel universes? And is that what it really comes down to? We're not understanding what they mean by dimensions?
No, they don't understand what they mean by dimensions, and there isn't multiple dimensions. What you read about quantum computers doing calculations in parallel universes is wrong. It's it's just wrong. There's no proof of that. It's just a silly thing that someone decided sounded cool, and again gets people to shut up, right? So a quantum computation you can do with pen and paper, just like you can do long division with pen and paper, but you
Slow
get the
down. You can
computer
do
to
long
do it.
division.
Actually, I
I'm not
don't
universe.
remember. I actually probably don't remember how, because I used the computer. That's the whole point, right? You built the computer because it is infallible. You give it the instruction and it carries it out faithfully, and it does so with blinding speed. Uh, and you'd rather just not do it yourself. That's exactly what a quantum computer does. I can carry out that computation that happened on Google or IBM or whoever's computer is being reported on. I can do that by hand with pen and paper. Now, if I did it, would I have done it in parallel universes? No, obviously not, right? Just because a machine did it and you don't know what's inside the machine, you just invent some mystical reason for it. It's just doing a computation you could have done, but you build the computer because it's faster and it does it without errors. That's all that's happening.
I don't know if somebody sold a lot of stock through that when they said it was when Google said they were going to other dimensions. I don't know if you saw their stock went to an all-time high. So it's not just, what I mean, everybody's peddling the bullshit. I don't think anybody
Yeah.
knows what they're talking about. So I'm really happy that you're able to, explain some of this. So you know what? Where should we send people to get more of your information, get more of your books? I love you clarifying all this. It really is kind of like, it's cool to hear the actual science behind it.
Yeah, Jesus, I should start um, a bullshit company. Sounds like I
You
could be
should, yeah,
rich.
or just a YouTube channel that debunks everything that they're
Right.
saying.
No, well, like you said, I make more money lying. Um, but yeah, my books, hopefully they're everywhere. Certainly if you want to get them online, a place like Amazon's the easiest. Oddly enough, they're often on sale and you can get them cheaper than even I can get them. Um, my website is csferry.com, and that, has a list of all the books and the places where you can find me.
And I really loved Quantum Bullshit again. It was a great book, and if people should, definitely grab that audiobook. Easy listen, and it really kind of like made it more palatable. I've been trying to understand this stuff for a long time, so really appreciate your work. Thank you so much for coming on.
Thank you.
All right, have a good one, Chris.